Yeah, so the EPA has for a long time regulated the underground injection of all substances, and that's include hazardous waste. It included water or gases for enhanced oil recovery, even for things like hydrogen storage. And they had a program called the Underground Injection Control Program. So when CCS started coming along, a number of people looked at those regulations and decided that they really weren't adequate, that for example, the CO2 EOR, there was basically very little monitoring that went on to demonstrate that it actually stayed underground. So if you wanted to use those kind of rules, you needed to add something to do with monitoring. For the case of the hazardous waste, it's quite different in that the hazardous waste tended to be either neutrally buoyant or actually negatively buoyant, meaning it would, once you inject it, it would tend to sink, whereas carbon dioxide is buoyant, so it has a tendency to float. So sort of a set of rules written for something that sinks as compared to something that wants to float needed to be revisited. The other thing is that the CO2 plumes, or the amount of injection, is very large compared to a typical hazardous waste kind of injection. So they have a new class. It's called Class 6, and it basically lays out the requirements for an operator that the operator must comply with in order to get a permit and operate a CO2 storage project. Well, I think that they're certainly very protective of the public, and they're very protective of groundwater. To the extent that they are, overly burdensome in terms of making the project cost more, I think that really it'll take some time to figure that out, because when you actually implement these projects, there's actually a fair amount of flexibility written in. For example, it doesn't tell you exactly what you need to monitor, when and how. It simply says, for example, you need to know where the plume is, and you need to know how large an area over which the pressure buildup has occurred. There are many different ways to do that. There are cost-effective, or more cost-effective ways, and more expensive ways. So it's really a question of, can the deployments be such that the burdens of doing them is not so great. But I do think they're quite protective. Yeah, so one of the big issues is long-term liability. So you've injected all of this CO2 underground, and during the operations period, you've got a lot of people looking at the project, you've got ongoing monitoring data, you shut the project down, and written into the rules are a sort of a 50-year period, at least in the United States, where you would be required to continue to monitor and report, and then at some point, probably 50 years after the project stops, the project could be shifted, for example, to another entity for long-term stewardship. So that's kind of the basic idea. But the question is who oversees this long-term stewardship? What kind of requirements are there for ongoing monitoring? If something goes wrong, if it starts to leak, who's responsible? So in Europe and Australia and Canada, those governments have made decisions that that liability would transfer to the government. That doesn't mean that the government would pay for it, that there would be trust funds that would be established that would basically have a shared risk pool amongst the various projects, that funding would be available, but it would be administered by the government, and the government would accept responsibility. In the United States, there's not a national policy on this yet. Some states have already made some decisions. So, for example, Texas indicated that at least for certain projects it would be willing to assume this long-term liability. The state of Illinois has also said that it would assume long-term liability. So it's right now the states are taking the lead in that issue, but in the U.S. it's still not fully resolved.